First, I would like to introduce ourselves. My name is Dilation and my partner Luvita Purnamasari. In this video, we would like to explain about transforming dilation in geometry. I hope you guys enjoy the video. In everyday life, of course, you have printed photos that you took for display, right? Well, in printing the photos, of course you can enlarge or reduce it according to your needs. Besides that, you must have seen a miniature that looks exactly the same as the original, such as miniature of Eiffel Tower, miniature of car, house, and each other. Guess what? It turns out that it used the concept of transforming dilation. Without realizing it, it turns out that in everyday life, we find many applications of the concept of dilation. But do you know what dilation is? If you want to know more about it, then skip this video.
To understand the meaning of dilation, let's take a look at the cube on this picture. The cube is transformed larger or smaller by the dilation factor k. When the factor k is larger than 1, so the cube gets larger. When the factor k is between 0 and 1, so the cube getting smaller. From that pictures, we can create the definition that a dilation is a transformation that produces an image that is the same shape as the original but has a different size. Also, we can see that dilation has its own fixed point called the center of dilation, and the distance of the point moved depends on the scale factor. If the scale factor is greater than 1, the image or the pictures is an enlargement. If the scale factor is between 0 and 1, the image is a reduction. There are two kinds of dilation. The first is dilation with the center of dilation is the O point with coordinate 0, 0. Then, the second is a dilation with the center of dilation is a random point A with coordinate A, B.
Okay, first I would like to explain about the dilation with the center of dilation is 0, 0. You can look at the following Cartesian graphic image. There is an object P, x, y, which is dilated to the center 0, 0 and with scale factor of k. Then an image appears from P which we call an accent P or P prime. At this picture of Cartesian graph, the distance from the O point to B point that wrote as OB is equals to K times OA. So, the x prime is equal to K times x, where K is a scale factor. Then, the BP prime is equal to K times AP. So, the Y prime is equals to K times Y. Both of these equations can be written as the matrix form like this. X prime Y prime matrix equals Kx Ky matrix. Then we can get out of the K became X prime Y prime matrix equals K times XY matrix. In another form, in the form of transformation matrix, we can write to X prime Y prime matrix is equal to K 0, 0 K matrix times XY matrix. Okay, next we will do the exercise. But before we go to the problem example, please consider the following formulations. So, X, Y matrix as the starting point, then the arrow over the vector D, O, K as the dilation vector with 0 as the point or center of dilation and K as the scale vector of dilations. Then, the X prime, Y prime matrix as the shadow as the result from the dilations. For the example, find the image of the point A 2, -5 by dilations D 0,3. So, the answer is we need to find A prime by finding its X prime, Y prime matrix. So, X prime, Y prime matrix is equal to K times X, Y matrix, where K is the scale vector. From the problem above, we know that the K value is 3 and the starting point is 2, -5. So, the result is that we just have to multiply it, so the value of A prime is 3 times 2 -5, and this is equal to 6 -15.
Moving on, we have now reached the explanation about dilation with the center of dilation is A, B. The concept is same as before, so take a look at this Cartesian graph. A is a random point and AC is equal to K times AB, then X prime minus A is equal to K times X minus A. Next, CP prime is equal to K times BP, then Y prime minus B is equal to K times Y minus B. This form can be read as this form, where A and B move to the right part of the equation. Both of these equations can be written as matrix like this, because K is a scale factor or a scalar. We can figure it out. Then, the final form is written like this, where X prime Y prime matrix is equal to K 0, 0, K matrix times X minus A, Y minus B matrix plus A, B matrix. Let's redo the exercise. Same as before, so this matrix is the starting point. The arrow over the dilation vector D with A, B as the center point of dilation. K is the scale factor and this matrix is the shadow or the result from dilation. As a reminder, I put the matrix from here. So now, let's take a look at the problem. The problem is, find the image of the point A 6,1 by dilation vector D with 2,5 as the center point of dilation and 3 as the scale vector. Okay, the answer is K is equal to 3, X is equal to 6, Y is equal to 1, A and B is equals 2 and 5. So we just change the variable with the value here. And we do the matrix operation until we find the answer. The answer is the matrix with the value 14, -7.
Nah, you have learned how about the dilation of point on Cartesian graph. Now, how about the dilation of line? Can we use the same method to delete a line? The answer is yes, we can use the same method to delete a line. Now, take a look at this exercise The given problem is find the image of the line 3x plus 5y minus 7 is equal to 0 by dilation D with 1, 2 as the center point of dilations and 3 as the scale factor. To find the answer, we know this problem can be solved by using the method of dilations with the dilation center is A, B. Because the dilation factor contains A, B as the point, so A is equal to 1, B is equal to, and the scale factor K is 3. Then we create the metric form like this. X prime y prime is equal to K times X minus A, Y minus B plus AB. Then substitutions the K value with 3, A value with 1 and B value with 2 and do the distribution and additions until we found the metric form x prime y prime is equal to 3x minus 2, 3y minus 4. From this part, we can create the linear form such as x prime is equal to 3x minus 2, so 3x is equal to x prime plus 2, and y prime is equal to 3y minus 4, so 3y is equal to y prime plus 4. So y is equal to 1 over 2 y prime plus 4 over 3. Now we do the substitutions for x and y to the line equation 3x plus 5y minus 7 is equal to 0. Then we get x prime plus 2 plus 5 times 1 over 2 y prime plus 4 over 3 minus 7 is equal to 0 until we found x prime plus 5 over 3 y prime plus 20 over 3 minus 5 is equal to 0. Finally, we found the form x prime plus 5y prime plus 5 is equal to 0. So, the image of the line 3x plus 5y minus 7 is equal to 0 by dilations D with the center point 1, 2 and the scale factor 3 is 3x prime plus 5y prime plus 5 is equal to 0.
Okay, that's all about dilation. Don't forget to like, comment, and subscribe. Thank you!